ask you all to try and get on the Wi-Fi when we have quizzes, but I'm also going to bring paper backups for anybody that can't get on, so that you can take it on paper. Just be aware of that. We're not going to let anybody get punished because they can't get on the Wi-Fi. I would like to keep hammering on this problem so that we can solve it. When we do take the exam, which will be on October 3rd, it will be on Canvas because I think the vast majority of students who have expressed it to me have said that they prefer not to take paper tests if they can avoid it, and I would prefer for you to not have to take paper tests. I will bring paper copies of the exam because if anybody can't get on, we'll want a backup plan. So I wanted to make you aware of that. I appreciate you working with me, and I think we will solve these problems. I think it was a lot better today, actually, than it has historically been, so I think we're getting closer. And maybe by the end of the semester, we'll actually have functioning Wi-Fi in this room. Who knows? I'm half kidding. Okay, so let's see. If you experienced hurricane-related issues and you didn't reach out to me, and that prevented you from attending class or whatever, please let me know. I am open to working with you if you were displaced because of a natural disaster. I think that's pretty much the definition of an excused absence. So, just know that. By the way, please, no shit posting on the general channel in Slack. I know it seems funny, but it's really hard. First of all, I have to read through everything. So I do read through every channel, everything you say. So just be aware of that. So no, I don't read it like in real time always, but I always have to read it, and sometimes I just want an emoji that is doing like the shaking my head pose, right? Yeah. Oh, you're going to turn me into an emoji? Yeah, here we go. I'll post later. If you want to turn me into an emoji, you let me know. There's only like 4 of me. I think I like the one of the cowboy hat the most. That's probably my favorite. Yeah. Okay. So anyway, so thank you for bearing with me. This is Growing Pains. I'm a firm believer in that we ought to be using technology to make things better, and sometimes that means we have to push boundaries, and that's honestly what I'm doing with the UFIT department right now. They've been really responsive. They have added equipment to this room. But I think that if we're ever going to get to the point where we don't have to have a bunch of Scantrons and bubble them in, then we're going to have to keep pushing this envelope. So, but I will include paper backups from here on out, just so that we don't run into big issues. Okay, so let's see. I don't think there's anything else. Please let me know if you do run into any issues. Last time we talked a little bit about software engineering. We talked about the process. Debugging as a process. We also started talking about exceptions, try, catch, and throw, which I explained again at the beginning of class in response to some questions. And the next thing we're going to look at is an approach that requires you to explicitly change things in the way that you run programs in your environment. Inside of IntelliJ, if you're using IntelliJ, obviously if you're using something else like Eclipse or NetBeans, the process is going to be a little different. But this is an approach which we call assertions. And the idea of an assertion is that you can put code in your program that says, I believe that this thing should be true. And if this thing is not true, that demonstrates that there is a massive error somewhere, or at least an error of some kind. That is what an assertion is. Its principal function is for you to make sure that things are working the way that you want them to work, and for you to know if they're not. So, for example, let's say that I had this code here, right? So I'm saying, I ask the user, what is the loneliest number? And let's say that we read that in using a scanner, and then we assert that it has to be a positive number. So we are expecting the user to put in a positive number. And if they put in a negative number, if they put in a number that is not greater than 0, so we're asserting, we're saying, this number should be greater than 0. If it is not greater than 0, then that assertion is going to fail. If it fails, and maybe this should be greater than or equal to 0, actually, now that I think about it. If it fails, it's going to send the message, the assertion message will be, negative numbers have imaginary friends. Get it? I know. Sorry, okay. Math jokes. So you get it now. It's that bad. It takes that long to pick up on. So if we say, what is the loneliest number, and I type in -1, then the output is going to be, in this first case, it's going to say that there was an exception, and it's going to be an assertion error in this case. And it's going to have our little message, negative numbers have imaginary friends. If we type in 2, then none of that code gets executed. The assertion passed, so it'll keep going. Now, assertions are unique in that by default, they don't just function. You have to turn them on. But they're very useful for debugging. They're used not just in Java, they're also used in C++. And they're a great way to catch little dumb errors, right? I've used assertions all the time. They're especially useful if you're like, there is no way that this should ever happen. And you put an assertion in there, and then if it does happen, you're like, well, obviously something is very wrong, right? And you know that in advance. You don't have to dig through a bunch of code to find it. Now, like I said before, many of these techniques, you're not required to use any one technique. I'm trying to give you a lot of tools that you can use. So you don't have to use assertions in your code, but I do want you to be aware of them if you see them elsewhere. And if we have assertions in our code, I want you to understand what they mean. In order to turn assertions on, in IntelliJ specifically, it's going to be under Run, Edit Configurations, Defaults, Applications, VM Options, and this -EA means Enable Assertions. That's what that stands for. Yes, sir?
So is this just the same as throwing an assertion error exception?
It is the same. It's just a little bit simpler syntax. So yes, you could technically create an exception and throw an exception if you want to, and it would have the same result. Yes. Anyone else? Okay, assertions are pretty. Yes, sir.
Do you have to use a ternary operator, or can you use else?
Oh, that's a good question. The question was, do you have to use the ternary operator? This is the only way that I'm aware that you can actually phrase an assertion operator in Java. If there are other ways, I just don't know them, but I know this one works. I've never seen it used any other way, so if they've added it, it would be in the name. My default will be yes, you have to do that. Yes? The question is it enabled automatically if you're not using an IDE? And the answer is no, it is not. By default in Java, so this is a difference in the Java versions. Old versions of Java had it enabled by default, new versions do not, which is really weird and terrible because it totally breaks backwards compatibility, and I don't know what they were thinking. But no, it's not enabled by default even in the regular old VM. Does that answer your question? And part of the reason is, I can tell you what the rationale is. I don't necessarily agree with it, but I can tell you what it is. The rationale is that you might want to have these assertion errors in your code, but you don't want them to go off if you ship your software, right? You don't want them to go off if somebody is running the code, because assertion errors are purely for the programmer's support. They're purely for you. They're not meant for the end user, right? So if one of these is showing up to the end user, that should never happen. That's why by default they're off, because they're supposed to be a developer tool only. I don't necessarily agree with that, but that's the way it is. That's the way that they have arranged the virtual machine in this case. Does that answer your question? Yeah. Like over-answer, I guess? I over-answered your question. I hope that's okay. Anyone else? Yes? Right. The point of this, the question was, is the point of this to catch a potential error? And that is exactly the point of this. The point of this is, if you have, this is kind of a trivial example because it's, I want to fit it on a slide, right? So it's a really short code snippet. You might have really complex code, but you might have some kind of expectation about the values. You might just expect the values you're getting could never be negative because you've already done some kind of filtering or something. And you might just want to throw an assertion error in there, an assertion statement in there, so that if ever there is a value that doesn't match your expectations, that it shows up, that you see it. Like that is the primary function, is to let you see when a problem is happening. Does that answer your question? Okay. Anyone else? Yes?
So do you think we should use the assertions like in our first project, since we're trying to handle anything reusable input?
I think the question was, should we use assertions in our first project to handle user input? I think if you don't find it overwhelming to do so, it definitely is helpful. If you find that you're already I think the most important thing is to get it to work with good input. Once you have it working with good input, that's when it makes more sense to start handling the edge cases and the error cases. So as long as it's not making you feel overwhelmed, they're a really useful tool. But I also don't want to say that you have to use them or that you should be using them, because if you can solve a problem without them and they're just going to confuse you, I don't want to do that. Right? I want you to solve the problem by whatever means you find most effective. So that's kind of a long-winded answer, but does that answer it for you? Anyone else? Okay. If I was writing the code, I would use assertions. That's what the answer that I'll give you. So, okay, so that's assertions. There's another really interesting feature, not just in Java, but in most C family languages, in fact, most languages, period, which is what we call the error stream. So up to this point, you've been very familiar with two different streams, the input stream and the output stream. Input stream is system.in, that's what we wrap the scanner around. The output stream is system.out, that's what we usually print to, right? So we print to the output system, we get input from the input system. There's also an error stream, which is just like the output stream, except it's only for errors. The only thing you print to it is errors, and it gets caught separately. In an IDE, usually that means it shows up in red, right? So when we see stuff showing up in red in the IDE window, that's usually because it's been pushed to the error stream rather than the regular standard output stream, as we call it. So here's an example, like a modification of what we were working from before, where we try to grab a number from the user, and if we run into a number format exception, we catch it. Before, we were just either printing something out to the standard output, or we threw an exception in another example. This time what we're going to do is we're going to say, print this message to the error stream. And that means it's going to show up in red, bold characters. In this case, we're printing that message, what, no, snafu, right? So if I type in blard, it'll tell me the loneliest number is 1. That's coming from line 19 here. And then it's going to print out this error stream. But the other thing is that these could actually show up in reverse. So what do you think is going on here? Why is the ordering here not necessarily known for sure? In fact, it looks opposite from the way the code is laid out. Why is that happening? Any ideas? Yes? So the answer you had is that it catches the exception first. And that is, I'll say that's correct with a little asterisk, right? You're really close. Basically, it is all about timing, which is the key point here. The error stream and the output stream, in the computer itself, they go in two different places. They go to two different places in memory, and it's only when they actually put them on the screen that they come back together. Now, which one gets there first depends on a lot of things, like what's going on in the CPU and a whole bunch of other stuff, and there's some random elements there, which means that the stuff from the standard input will always be in order for the standard input. The stuff in the error stream will always be in order for the error stream, but if you mix the two together, they might not come out in exactly the order that you put them in. Does everybody understand what I'm saying there? Okay, so the reason I'm pointing this out is because you shouldn't try to mix them for the same purpose, because you don't know what the ordering is going to be. However, it's a really useful tool to split out error messages onto the error stream, because another thing you can do that's neat in many systems, including Unix and Windows, is you can actually catch just the errors. You can put them in a special file. We're going to talk more about log files later on in the class when we talk about file I/O. But we can actually route just the errors somewhere else. But in the IDE, it's nice because they show up in bright red colors, right? So it makes it really easy for you to catch it when an error is there as opposed to just a regular old statement. So just to reiterate, the error stream acts just like the output stream. The main difference is that it gets stored in a different place and the way it gets treated by the system. In the case of the IDE, it shows up in red as opposed to like black or white, which is what the standard output stream is going to show up in. But otherwise, everything's the same. All the functions are the same. Everything else is the same as system.out. All right, any questions up to this point? All right, so, yeah, this is just a note. They're not coordinated, right? So they don't necessarily keep the order in between. The next thing I want to talk to you about is debuggers. So there's a whole set of software built into your IDE whose only purpose is to help you find errors. And that's because we spend like 90% of our time dealing with errors. So it's really important to have good tools. This is an example from IntelliJ, but the vast majority of debuggers have a few major components in common. The first one is what we call breakpoints. A breakpoint is a way for you to set a point in the program, usually a line number, and it says when the program reaches this line, I want execution to stop so that I can take a look at the state of the program. I should say pause, because it's not actually stopping the process, it's just pausing. But it's a way of pausing the execution so that you can look and see what's happening in a program before continuing. And this will also let you take steps through the program, line by line by line. And as you step through the program, if you set a breakpoint and you step through one statement by one statement, you can actually track how things in the program are changing, how data is changing, how the variables themselves are changing. And that's these little icons right here in IntelliJ. One of them, I believe this is step into, this is step over, this is step out of. But all of them let you step down through the instructions and execute them one at a time. Other than the breakpoints and step through, there's also a stack trace window, which will tell you what things are being executed. Now, most of our programs are pretty simple up to this point. They just have a main function, so that's the only thing that's going to appear in the stack trace. But we're going to start to see more complex programs pretty soon. And finally, probably the most important part, other than the breakpoints themselves, is the variable watch window. And this tells us what the values of the different variables are. We can look at any variable we want to, and we can see the value that is being stored in that variable. So all the variables will show up in this watch window. And as we step through the instructions, the variables in that watch window will change. So if we do I++, then we'll see the value of I in the watch window go up. If we do I minus minus, we'll see the value in the watch window go down. It'll let us track what the values of the variables are as we go down through the program. And I'm going to show you an example in just a moment here. Now, something really key is that almost universally, if you're going to use the debug functions, you're going to have to execute in debug mode in your IDE. That in IntelliJ, it's a picture of a little bug. I think it's also a picture of a little bug in Eclipse. I don't know what it is in NetBeans, but I'm sure that if you're clever enough to use NetBeans, you can figure out how to put it in debug mode. But every IDE that I've ever come across, I'm pretty sure it's a universal thing. It has a debug mode, and you have to run debug mode in order for the debug functions to actually work. So that's kind of a visual example, but I'd like to go ahead and show you in IntelliJ itself an example of this. So I'm going to go ahead and open up a project for us to take a look at. Alright, so, oh good God, that's squeaky. So if you want to follow along while I'm doing this, please feel free to pull up IntelliJ and I will try to guide you through these features. Now I'm going to try and fit it all in the window. There we go. Almost. Let's see here. Which one should we try? Oh, this one is a great one. Let's try this one. Okay. So, let's say that we put a breakpoint right here, so where this little red dot is. The way that you add a breakpoint in an existing program is over here on the side. You're just going to click like that, and that will set a breakpoint. That means when we go to run this program, it's going to stop right there. If I go up here and run it in debug mode, it's going to show me the output window here. Let's see. Resize this. And I can't resize it. I don't know what's going on here. I can't resize this, but yeah, you should be able to. Usually. All right. Let's try this one more time. It'll go gadget debug mode. Oh, I'm running the wrong. That's why. Okay, I figured it out. I need to go to catch for the win as my program. Let's try now. All right, there we go. Okay, so as you can see, when I run the program, it's going to stop the execution. If I look over here, it's going to have any information that's in my program. I have info, please, which is a scanner type. This is the line where after I execute it, the variable lonely number should show up. So if you hover over, you can see what the commands do. This is step over, this is step into. I want to step over this instruction. In other words, I want to go to the next instruction. So if I click that, then now lonely number has a value. It has the value 1 that we just set. Does that make sense to everybody? Okay. Now I'm going to read something in from the user. So I'm going to go ahead and let's see. Let's set another breakpoint inside the catch window and not down here. And I'm going to restart the execution. I'm going to stop stepping through, and I'm going to hit play, which will restart the execution. And now, if I go to my console, it's waiting for me to type a number. So I'm going to type, let's try an invalid entry first. Let's type lar. Then it's going to go to my next breakpoint, which is down here. So it stopped again, and it's right here. So if I go ahead and I step over, it's going to go ahead and print that line, right? Because I just stepped through. And then if I step again, it's going to print the output, right? If I go ahead and stop this, and then I run it again in debug mode, let's see, let's turn this one off. And if I want to restart execution down in the debug window, I can just hit the play button, right? So if I go back to my console, I can type in a real number like -1. If I take -1, now it's breaking down here. If I go back to my watch window here, I can see that now the value of lonely number has changed to -1 because that's what I typed in and got parsed and so on and so forth. Okay, does anybody have any questions about this basic process of debugging, the basic layout of these windows and stuff? Okay, so here's something I'm going to say all of you should be doing. When you're trying to find bugs in your project, you should be using this debug mode. You should. Like assertions, use them if you want to, if you think they'll help you. But this debug window, you should be using it. If you're not using a debug mode, then you're basically trying to debug with one hand tied behind your back, which is okay if you really want to do that. You know, if you like to cause yourself pain, if you enjoy that, that's okay. You can do that. I don't recommend it, but you can do it. So I'm not going to force you to use the debug window. I'm not going to say, oh, send me a screenshot of you debugging. No, I'm just going to tell you that you will be miserable if you don't. And that's up to you. If you enjoy misery, that's fine. But I don't recommend it. I've had plenty of misery, and I can't recommend against it enough. So back in my day, we didn't have debuggers. Kids, get off my lawn. Okay. Okay, so that's the debug. We are going to take a break in a minute, so hang in there. We're almost there. Okay, so we talked about the debugger. And now, before we take a break, I want to talk... Actually, you know what? Let's take a break and then we'll talk about version control. So please be back in 12 minutes at 4:05.